Hi everyone, I'm Nitzan from Hexagon. We're going to talk about stateless environments and serverless environments and how do you handle the different problems that you can have in this kind of environments. So I'm from Hexagon, and we are a company that is focused on serverless and on monitoring in production and troubleshooting. So we help customers and companies use serverless in production better so they can understand what's going on and fix problems fast, because there are many challenges there. And a few words about me. I'm an engineer, so my background is mostly in cybersecurity, reverse engineering, infrastructure. And for the last year and a half, I'm one of the founders and the CEO of Hexagon, and here in Tel Aviv. Actually, I have this thing. It's okay. And what we're going to talk about today, so I'm going to start with an introduction about serverless in general. Of course, stateless is not just serverless, but I'm going to focus on it because it's one of the main use cases today for stateless environments. And of course, many of you are working in the cloud, so it's very relevant for companies that are starting in the cloud today and also already in the cloud. And then we're going to talk about different problems that you can have in these kind of environments and what are the best ways to handle them, including technologies such as distributed tracing and automation for many of the things. And then hopefully my goal is that some of you can actually take this knowledge and start experimenting with serverless in your job today. Even if it's for small things, it can be very helpful. So, quick introduction about serverless. So I don't know how many of you here are familiar with serverless. Okay, so most people, when they think about serverless, they think about stuff like AWS Lambda, which is the most popular function as a service today. But serverless is not just AWS Lambda, it's a concept of writing software without managing infrastructure or less managing of infrastructure, and basically focus more on your business logic. So as a company, you can work faster, you can spend your developers' time more efficiently, and the DevOps times on things that are not just scaling more, scaling less, managing the infrastructure every day because there are spikes and so on. So many of these things are taken care of by the cloud provider when you work in serverless. And in practice, it's a combination of both services such as function as a service, such as Lambda. And today you can have also container as a service, for example, AWS Fargate, if you know it. And then mixing those with managed services and APIs, for example, a database, storage element, message queue, anything you need, you make it managed. And then you get a serverless application that is really scalable and managed for you. And eventually, as a company, you can go to market faster this way. And the most popular one is by AWS, so Lambda, but there are similar services by Azure, Google, IBM, and also some open source projects like the Knative by Google recently. So basically, these are services for function as a service. And the benefits for a company using serverless is, first of all, the financial benefits. So basically, you can save a lot of money on the cloud compute bill. Because if you look at the right side, this is how a server is usually working in a company. There are traffic spikes. And in many companies, the utilization of servers is 10 to 20%. So basically, why? Because there is a spike and you don't know when it's going to come, so you have to be prepared. But basically, 80 to 90% of the bill is paid for nothing. So pay-per-use means that you will only pay for the time your code is running. So every 100 milliseconds, you're being charged very little. Of course, if you take it in total, it's not necessarily so little, but you can save a lot of money. And companies saved 90% of their compute by moving to stuff like Lambda. For me, the biggest advantage is actually the other stuff, the auto-scaling, and it's called low ops. So instead of DevOps, you do less DevOps around infrastructure management and more around, for example, automation and testing and things that really impact the application, and not just, making sure things are working now in production because there are traffic spikes. So eventually, as a company, it's all about developer velocity. DevOps in general, it's a lot about developer velocity, but serverless is, again, developers can just write their code, ship it, and the cloud provider will take care of a lot of the stuff. So it sounds great, right? It sounds like many of you want to try it right now. So there are limitations, of course, it doesn't come free. So first of all, the functions themselves are limited running time, limited memory. So basically, for example, a Lambda can run, it was 5 minutes, now it's up to 15 minutes. It's not bad, but it's not suitable for everything. So you need to design your application differently. You need to choose how much memory the code has. So the more you choose, the more you pay. So you have a very good reason to choose 128 megabytes for a Lambda, but maybe the Lambda will get out of memory because it's just not enough, and you don't know how much you want to choose. So that's a problem again. Then you have those cold starts, so it takes some time to start sometimes, so it can impact performance. And I'm going to talk about stateless as one of the, it's not exactly a limitation, it's a part of the design, but it makes you design applications differently, and it makes it more challenging to troubleshoot and understand problems that happen in production. And eventually, if you think of serverless applications, the way they look like, essentially it's a microservices architecture. So you have functions and you have services that are all connected in between. And if you take a look at the right side, you see an example of Lambda triggered by an API gateway, which is a web server service. So when HTTP request comes in, the Lambda handles the request, creates a file in S3, which is a managed service for storage, triggers another Lambda that takes this file and does some calculation, writes it to a database, DynamoDB, which is a managed NoSQL database. So there, everything is completely managed. After you deploy this and it's running, if it's working, you can basically forget about it, about scale, about anything. It's just going to work for 1,000 users and 1 million users. It's going to be the same, in theory. So the serverless applications are highly distributed and highly event-driven, which means that because each function is very small, you end up with bigger architectures. So in terms of software design, it's more complicated, more challenging to design, and more difficult to operate, if you think about the more complicated problems that you can have. And one of the key things that you need to consider is using as many managed services as you can via APIs. So even stuff like Auth0 and Stripe can save you from writing code, and it will eventually make your Lambdas smaller and makes them more efficient. So using more and more APIs is one of the key characteristics. And just an example from the reInvent that I was in about 2-3 weeks ago. This is an example from HSBC, a company that you all know in the banking industry. And as you can see, they have a pretty interesting serverless architecture in production. It's not just on paper, it's really in production. So it's not just a buzzword. People are using it today to develop software faster. Everyone is doing it, including us. So we are a company, pretty small startup company. We're just 11 people, but we have about 400 Lambdas in production in very high scale compared to a company our size, because we digest all the events from our customers' environments. And we use it a lot because it does scale. It is very good. It's not easy, but now that we are in it, we are not going back. I mean, it's just adding more because you kind of get addicted to it. Okay, so what are the challenges? Eventually, I described some characteristics, but if you took an example of this application that this guy on the right, Jan Kuh, is one of the top bloggers in serverless today, is an engineer that did this experiment of migrating a monolithic application into serverless. So on the right side, you have a fully serverless application, 100% on AWS, and you see the complexity. The left side is very simple, the right side is just huge, you know, the number of functions, the APIs, the events. How are you going to operate this thing? So even if you have this on design, you deploy it into production, what you get from the cloud provider is just logs and logs and logs. It's just not a good description of what's really going on in this kind of application. What about all the events, all the APIs? How can you fix issues fast? How do you know the customers are getting good experience with this kind of application? So these are big challenges. And one example for troubleshooting, so if you have a problem in this function, maybe there were 5 events before that came, and you want to understand exactly why it happened, but what you get is basically logs and logs and logs, and logs are not the right tool for using to troubleshoot distributed systems. This is something that people already realize today. So just one example. And the community agrees that debugging and monitoring are the biggest challenges today in serverless. This year and the year before, it only gets more complicated, and the tools are still very basic, the ones that provided by the cloud provider, for example. So let's go into error handling. So I had some introduction about serverless, so I guess now you are more familiar with what serverless is. Now I'm going to go a bit back and talk about error handling in general. How do you fix problems in production? How do you understand that there is a problem? So in old traditional applications, not necessarily old, but in traditional applications, monolithic applications, for example, you have a server, you have an application, there is usually a log, and log is a very easy way to use to understand what happened. If the log has the information inside, you can go and see what happened, and you know, maybe it's very helpful. If it's not enough, you can connect to the machine. Maybe you can even connect the debugger to the staging environment. You can do different things to kind of understand what happened. So that's the way it's used. It's done until today, and every kind of products, they have logs. And companies do use stuff like ELK to aggregate logs from all the projects, all the products, and search, and it's very straightforward, right? Now, what happens in stateless environments? So serverless is stateless. Each one of these functions doesn't have a state. It has an event, a trigger. It starts to run, then it stops to run. It can happen 1 billion times a day, but still it doesn't have a state. So you have to take the state and save it somewhere, usually a database, storage, and so on. But then eventually it's all events. Function wakes up, triggers an event, publishes a message, triggers another function, and so on. So this is what I mean by stateless and event-driven. And then it's pretty difficult to troubleshoot because you cannot connect to any server. You cannot connect a debugger. You only have logs, but the logs are not in context. One function can write a log, and 1 minute later, the other function is triggered, writes another log. How are you going to know that these two are connected together? Basically, and you can have billions of them. So it's very challenging, and it's even difficult to know what the system health is. So I can measure if the functions are failing, that's okay, but is the application working? Are the customers getting the right experience? That's a tough question. So what can you do in these kind of environments to understand what's going on and to troubleshoot the issues? So let's talk about some problems that can happen in serverless application. So the most typical problem is you have a bug in the code, an exception, not necessarily a bug, but a problem in the code, and then you can handle it. You can catch the exception, you can write it to the log, but again, if the logs are not going to tell the entire story, how are you going to tell the next function in the chain that something happened? Are you going to publish a message that describes an error to the next function? It's not really a good practice. So again, even problems that are small can be difficult to trace back. You need to somehow understand what was the entire story. And then you get timeouts out of memories, so it's pretty much like someone will take the computer out of the plug. The function will just get a timeout. AWS is measuring, and that's it. The function is dead. You cannot do anything. You cannot recover from it. That's one of the worst things that can happen in serverless. And maybe it's not even because of your own code. Maybe you are calling some API for authentication. It doesn't reply for some reason, and your function has 5 seconds limit, and it's dead. So these problems are very complicated to predict. So again, it's difficult to predict and to troubleshoot after. So just for example, so I'm going to talk about one of the useful ways to handle these problems. Since, as I described, it's pretty difficult to understand and to fix and to think about it in advance, usually people use something called retries. So retries are kind of like they sound. You do the same thing again, and you hope that it will work this time. Of course, it's not so simple because you cannot always do something twice with it working. Sometimes it's going to change something. And some of the examples of retries are, for example, someone called your application and you failed, and then the other person chose to call it again. This is their choice. They can call you twice. If they think it's going to work, that's fine. That's not your problem. So this is what I call synchronous events. So if someone chooses to do something twice, that's fine. It's up to you. But the more interesting use cases are things that are actually embedded in the cloud provider infrastructure. So for example, on the right side, you see the SNS that's triggering a Lambda function. Then the Lambda fails. So by default, the SNS will try to run the Lambda up to 2 more times, total of 3, in this specific time interval. So for example, it failed quick, it will try to run it again and again. So is it something good? No. Well, you don't know. It really depends what this Lambda is doing, but this is the default way. And the same happens with Kinesis, which is stream-based events. So Kinesis is something that can be used to analyze data quick. So you get pieces of data and you want to analyze them. So it will try to analyze it again and again as long as the time didn't go away. So again, retries are things that are being used, and they can be very useful if your application is designed in the right way. So what can happen when you do a retry? Eventually, you change the logical flow. If a function is expecting a number, and then it takes this number and pays this amount in dollars, you don't want to do it 2 times, because you're just going to pay the money twice. Obviously, this is not a situation when retry is going to be effective. So when retry is a good thing to use, when system is something called idempotent. So this is a mathematical property that, as described in Wikipedia, it's a property of certain operations in mathematics and computer science that they can be applied multiple times without changing the result behind the initial application. So in some situations, when the application is of this property, you can do things multiple times. So some examples. For example, if you update the database, you can do it more than once, it's gonna stay the same. That's something that you can do more than once, as long as nobody else is trying to do it at the same time as you. If you want to authenticate the user, you can do it twice, because it will remain authenticated. And same for if you want to check if a file exists. If it doesn't exist, you create it. If not, it's okay. So it's things that you can do more than once. But that's nice to say, but eventually when you design an application with hundreds of functions, thousands of functions, how are you going to design each point to be of this property? It's pretty difficult, and it's not the way developers think. It's not something that people are used to. And that's why there are services that can help you do it. So for example, something like step functions. How many are familiar with step functions? Yeah, it's pretty new. Not so many people still use it in production. I mean, relatively to Lambda, for example. But it's basically an orchestration service. So you design a state machine in AWS, and then each part is a Lambda function or some condition. And if it happens, it goes to the next step. It's like you design a state machine in general, but things inside are already meant to deal with retries and everything like that. So basically, this is very resilient. Once you deploy this and you do it right, it can work very well with retries. Of course, it doesn't come cheap. I mean, it doesn't come free. It costs an additional amount that you pay to AWS, but of course, it's a managed service like anything else. It can save you a lot of time, so maybe it's worth it for you. And just some example from what we do. So this is a screenshot from our product. So for example, if you have this transaction involving Lambda functions and the second function failed, one of the things that we do to save a lot of time is to automatically say, hey, you had retries, so these three invocations are actually part of the same transaction, and you don't need to go one by one and understand what this is in relation to. So just a way to save a lot of time when debugging, just an example. And this is another example. So if you have a Lambda that is triggered by an SNS, so you can take the whole logic of the Lambda and actually trigger a step machine instead. And then you can do a lot of logic inside with all the retries and so on. Many people use Lambda for kind of cron jobs, like a substitute to cron jobs, because it's very easy. But this is not usually what I'm talking about. I'm talking about actually logical applications. So if you have a complicated script, you want to convert it into Lambda, maybe you can do it in a step machine that will have different conditions. And basically, once you deploy it, you can forget about it if you do it right. This is just some example. Don't look at the code so much, but this is how you can describe a step machine using a YAML with Serverless Framework, which is one of the popular tools for deploying. Like people use it in CI/CD a lot. So you basically describe it as a YAML file, you deploy it, you can do it in a cloud formation in different ways, Terraform and so on. Okay, so we talked about stateless, we talked about error handling and retries. Now the second part of the talk is going to be about observability in general, and I'm going to talk about observability for stateless environments, and how do you know that applications are working as you expect. So eventually observability or monitoring, or everyone calls it in different ways, you always have the same goals. You want to know that your system is working. So if you have something in production, you want to know that it's working. You're not going to wait for a customer to call you with a problem. You want to get some alert, some number, some measurement to tell you that it's working. And that's a difficult question, because what is working? Is working equals 0 errors? Is it latency less than 200 milliseconds? It depends on the application. So this is a tough question usually. And in complex microservices applications, it's pretty difficult. And then you want to be able to fix problems fast. So even to know about the problems before they happen, and then fix them as soon as possible, because your customers are experiencing problems. You want to give them the best experience. And the last thing is optimizations and bottlenecks. How do you detect them? How do you make decisions based on this data? And in serverless, it's not just performance, it's also cost, because you pay per use. So if you can improve something to be 50% faster, you're going to pay 50% less dollars. So it's another reason to want to optimize your systems. So I'm going to go one by one for these things and to see how they apply in stateless and serverless. So let's say you want to track your system health, and you have this big application that I showed you before, how do you know that it's working? Is it essentially just checking the functions? Is it enough to look at the function metrics? So I can look at the errors, I can look at the duration. So first of all, it is useful to look at functions, and by looking at the function metrics, you can identify problems very easily. So you know if all your functions are failing all the time, there's a good chance that the application is not working very well. But it doesn't mean that if they all don't fail ever, then everything is working. But it's a good thing to make sure you don't have many errors, timeouts, out of memories, cold start. These are useful to identify via the function metrics. But then if you look at this application, you see that it's more than just functions. There are flows, there are events, there are APIs, everything is connected. And if you want to understand what the user experience is, maybe just looking at function metrics is not enough. And eventually, a serverless application is more than the functions. It's a combination of functions, APIs, and what we call transactions. So a transaction is basically something that starts, for example, with an HTTP request, triggers multiple events until it ends. So this is really something that tells the story of the user with the application. And if you think about troubleshooting, and I showed this example before, so again, the functions are not enough and the logs are not enough. What eventually you would want is to somehow track those events together all the way to the end, and then troubleshoot faster and understand the performance from end to end, and not just for particular functions. And this is just an abstraction of what a transaction looks like. It's just arrows, basically with a start and an end. And if I talk about asynchronous invocations, how you want to connect them, so for example, if the first function is triggered, you would want to know that these functions are triggered later. So being able to connect these two together is something that's not possible to do via the logs, because the logs don't have a context. This is something that is related to tracing. I'm going to talk about in a second. And the second thing is to also identify requests outside the cloud providers. For example, if you call a different cloud provider like Azure, if you call authentication, you want to know how much time these things take, because they can cause your function to time out. And also you're going to pay. Each time you're calling an API, you're paying money, and there is a good reason to do it fast. And now I'm going to talk about distributed tracing, which is one of the key technologies to understand distributed systems and servers in general. Well, how many are familiar with distributed tracing or heard about the term? Cool, so many people today use microservices, containers, and some of the things that people realize at some point is that I can't really understand what's going on just by looking at the logs of the service, because there's not just one service, there are 4 services, they are connecting, talking to each other, and this is what's called the distributed trace. Something comes in, going to multiple services until it ends, and the trace is something that tells the story of this request, for example. So distributed tracing is a technology to understand distributed systems, and this is just one example of a client billing application. And eventually, when you get the distributed tracing data, you can put it in some tools. For example, this is Yager, a popular tool for visualization of the timelines and waterfall charts, so you can quickly identify how much time every operation took. But how do you get this data? How do you know how everything is connected? It's not so easy. And this is why people use different frameworks. For example, Open Tracing, Open Census, they are very popular for microservices to implement distributed tracing in your company. And companies today are putting a lot of focus and effort into training, into implementation of these services. I know they use it in some of the bigger companies in Israel. And once you do it, you can gain great success of visibility, troubleshooting, and so on. The problem is that it's difficult. It takes a lot of time, a lot of maintenance. There is a potential of errors. And eventually, you're going to tell your developers and DevOps, OK, now you have to spend 30% of your time doing this thing, because otherwise we have no idea what's going on in our production. So people want to go fast, they want to deploy faster, go to market fast, but then they have to go back. Oh, wait, we have no idea what's going on. We need to do this thing. So that's kind of a balance that is going on today. And if you take it to serverless, then the question is, does it really make sense? Does it make sense to implement something so manual in applications that's supposed to be so fast to deploy, and maybe have thousands of functions? So does it make sense to deploy it in thousands of functions and maintain it over time? What about the developer velocity was the main reason to go into serverless? So what we are working on is to do it automatically and to save you a lot of time. And eventually, automation is generally something that I really believe in, not just serverless in general, in operations, in development. Everything you can automate today you will gain great amount of time, because eventually over time the applications become complicated and maintaining those can take a lot of time. So automation is very, very helpful. And I'm going to talk about some example that shows what you would expect from distributed tracing for serverless, how it will help you. So if you think about this trace, I mean, this request comes into an API gateway to a Lambda function that does authentication with Auth0, an external API. It publishes a message to an SNS, which is kind of similar to RabbitMQ, and then triggers another Lambda function that fails. So now you have the failure, and we saw how it looks with logs. You just get logs, but it's difficult to understand what's going on. So distributed tracing enables you to really trace back what happened. So starting from the first function to see what was the error, actually the exception in the code, to look at the function parameters, what was the running time, was there a cold start, anything that happens in the function, and the log. Then going back to the SNS to get what was the JSON message that actually triggered the Lambda. So now you go a step back, you know what was the input for the Lambda, even if it wasn't in the log, you have it by the trace. And then for the first Lambda to see what happened there. So, oh, the authentication failed. So maybe the problem was that the first Lambda continued even though it failed authentication. So the problem wasn't actually in the second Lambda. And the Auth0 returned that the authentication indeed failed, 401. And all the way, the API gateway can tell you who was the user involved in this request. So everything is automatically traced. So when something happens, you can go inside and fix it in minutes instead of hours or even days. This is what we've seen companies doing. And another example why you should care about external API. So in this example, you use Auth0 and Twilio. I don't know if you see the numbers, but basically Auth0 is about 700 milliseconds because it was configured to the wrong region. And you work in US East, but maybe Auth0 is configured to Europe. But then these 700 milliseconds compared to 50 milliseconds in all the rest adds up. And if it happens a billion times a day, it's going to be a major bottleneck in your application, and maybe 80% of your total cost is going to go just waiting for this API. So understanding the bottlenecks for any external API is also very important. And the last thing is also to kind of take these individual transactions and start to gain insights about the performance of the system. So of course, it's good to look at individual transactions, but what about the performance overall? So what is the user experience in the aggregated way? So is it 1 second over time? What are the errors? Where is the bottleneck? Not just now, but in the last 24 hours. So seeing these kind of business flows can really help you and can tell you, okay, I have a user subscribing to the system, the subscription takes 500 milliseconds, and this is happening 1 million times a day. And I have another one that is a payment transfer, and this is happening 100 million times a day, and it's taking this much time. Very important for me that this one will be much faster, and the other flow maybe is not that important. So you can choose and make decisions on optimizations and say, I want to optimize this flow because it's more frequent and it's more important to my business. And then you can make these decisions. Okay, I think the last thing I want to finish with is that, first of all, serverless is not something that AWS made up to just to make more money. Everyone is doing it. All the companies are experimenting with it. And eventually it's meant to develop software faster and to ship it faster. So companies can basically go to market faster. So if you want to adopt serverless, think event-driven. Don't just think of Lambda functions as a substitute to a cron job. It's something that can be used in production for really meaningful applications, very high scale, and companies are doing it today. But if you do it, you have to design it properly, and you have to use the right tools. So orchestration, like step functions, is very helpful. And automation is, again, it's something that can help you really enjoy the benefit of serverless. Not just say, I want to do serverless, but then I'm going to spend 50% of my time understanding what's going on. So using the proper tools can help you move faster with serverless and really enjoy all the benefits. And eventually go to market faster. So thank you. If you have questions, feel free.
Does X-Ray provide most of the observability stuff?
Yeah, X-Ray is one of the tools provided by AWS for profiling of Lambda functions. So you can say, I want to understand how much time I'm spending in each of my functions, and you can start X-Ray, and then it will tell you, oh, the DynamoDB took this much time. It's useful. We actually don't use it, but some companies use it for different measurements. It doesn't really give you the entire picture of the end-to-end events because it only goes in the function and what's going on around that function. And it's not, a monitoring product. It won't send you alerts. It won't let you understand the application, just the basic latency measurements. So it's a tool that can be used usually with other tools. So some people take X-ray data and they stream it somewhere, stuff like this. Yeah.
How do you manage counters? Like something like Graphite, for example?
Yeah, that's the problem. You don't manage counters. You need to use a database, or you need to use something like step functions that will do it for you. You don't store a variable in the memory of a function to use it as a counter. Also, the cold start, what is a cold start? I mean, the way it's all implemented is by containers. So there is a container, it's being set up, and then your code is loaded and it's running. And these containers are not always starting from fresh because they want to do it fast, so they are staying there, and then your variable will keep in the memory. This is actually how we identify cold start in our library. We have a library that does instrumentation, but you don't know when the container will die. It happens between several minutes to hours, but when it's gonna go fresh, there is nothing left there. So basically, you don't want to use cold start, you want to use an event-driven architecture, where if you want to counter, it can go to an NoSQL database, for example.
When you say automatic observability, there's no need to instrument the Lambda function with anything?
Yeah, so to get distributed tracing in general, in theory, it's not possible to do it without going inside the code in a way. You need to somehow tell someone what's going on. Specifically, what we do automated instrumentation. So we go inside the code automatically. You can do it via, plug into the deployment framework. We are now partners of AWS Lambda layers. I don't know if you know it, but basically you can have something already included in Lambda before it's loaded. So you can have us as well included in the Lambda, and then the code will be automatically instrumented. So as a developer, as an operations person, it can be zero touch, basically. You don't have to change even your code repository. It goes just when the code is going to production, that's where the library goes in.
As part of the pipeline?
So if you use the layers, the AWS Lambda layers, it's already in the AWS platform. So when the Lambda is loaded, a library that you choose is already preloaded with it, and then it goes inside. So there you don't even have to be aware. Of course, sometimes you do want manual stuff if you need. No, technically it's a wrapper for the function, but the way the code is changed is automated, so you don't need to annotate anything on your own. Yeah.
So usually when you use things like logs.io, you can do like group by specific criteria or something like that, and it gives you a high-level view of the stack or the service. In your products, you really tackle I want to debug this specific function. How do you provide a way to get a high-level view of the application?
Yeah, so actually, if you think about something like that, right? So this is the difference between going inside a function and going outside the application. It is exactly that, the distributed approach. I think what you mean is stuff around not just functions, but other services in AWS. So I want to monitor, I don't know, my S3 or something like that. Is that what you mean?
For example, I want to have, I want to see a time series chart of 500s per function. So yeah. How many 500s I get per those critical steps in my infrastructure?
Yeah, so this is something that is on the function level. You can do it, you don't need distributed tracing for that. You can just look at the return value of the function. You can put it in the log, as you said, and put it into something like a log aggregation service, or you can use the metrics provided by the cloud provider in some ways. Our focus in the company is on APM, so it's basically the whole application, and this is one of the things that you can, for example, what you describe, you can do something like custom metrics. So you can send a custom metric from the function every time it's running, and then monitor that the number of times you get this value in the metric is not more than X%, and then get alert. This is one option to do it. But what you described is also a valuable option. But to connect these things together through the SNS, through the DynamoDB trigger and Kinesis trigger is the challenge that we are tackling, because these things cannot be understood just from logs, basically. Okay, thank you.